Today we're going to look at finishing up our notes for section 4.7. We've been talking about the quadratic formula. Do you guys remember what it looks like? X equals what? Okay. So when we solve a quadratic equation using the quadratic formula, we are finding where it hits the x-axis. Yes? This question says, your school's jazz band is selling CDs as a fundraiser. The total profit P depends on the amount X that your band charges for each CD. So P is the profit, X is the cost of the CD. The equation P equals negative x squared plus 48x minus 300 models the profit of the fundraiser. What is the least amount in dollars that you can charge for a CD to make a profit of 200? If we looked at the graph of this, just y equals negative x squared plus 48x minus 300, we would have an upside down parabola. Yes? Has a y-intercept of negative 300, so we're way down here at negative 300, and it's an upside down one. The question is, what is the value for x that would get me a profit of $200? Well, 200 is somewhere over here on my y-axis, right? I don't know for sure where. It might be up here, which means I don't even get to a profit of 200. There's no x value that would get me that. It could be right here, where it's going to hit in one spot, and there's just one x value that gets me a profit of 200. Or it might be down here, where there's two spots. There's two different values that I could put on that CD, both of which would get me a profit of 200. Okay? What we're going to do, instead of trying to solve for where it's 200 on this side, we're going to bring that 200 to the other side and make a 0 on one end. That way we can use our quadratic formula to solve it. So what's really happening is by moving that and subtracting 200 over here, we're taking our parabola and we're shifting it down 200. So the places where I would have hit a line of 200, if I shift this all down, are going to end up down here. Does that make sense? And the quadratic formula allows me to solve for my x-intercepts. So I'm just moving it all down so that I can hit that x-axis. Okay? So we start with a 200 in for our profit. We're going to subtract it to the other side to create that 0. And now we can use our quadratic formula. So x equals the opposite of b plus minus the square root b squared minus 4 times a times c, all of it divided by 2a. Now, we have to do some simplifying. And before you start looking at your calculator, I want to talk about how we're going to type this in. So under my square root, I have 48 squared. What do I get for 48 squared? Okay. And now if I look at the 4AC piece, I have 4 times negative 1, that's negative 4, times negative 500, that's 2,000. So I'm subtracting 2,000. So inside the square root part, we would just have 304. Okay? Now, we would never pick up a CD at the store and look at the price tag and have it say that. Right? So we need a decimal approximation for that. That would be really cool. I might have to just open a store just to do that. But we want a decimal approximation. Now, your graphing calculators are great at letting you see what you've typed in, right? So what we want to do is we want to enter this all in one big long string. But first I want you to tell me what is wrong with typing it in like this. Good. It's only going to divide the square root of 304 by that, right? So I need to take the whole numerator and divide it by -2. That means I have to put that numerator in parentheses. Now, a lot of students will type things in just in little pieces. They'll say, I'm just going to figure out what -48 plus the square root of 304 is, get an answer, and then type in that I want to divide it by -2. I want you to get used to typing it all in as one. Because once you've typed it in for the first one, for the plus sign, you can just recall that entry for the -1. So go ahead and type this in, get your answer, but don't clear your screen. What did we get for the positive sign? Anybody got it? Good. All right, now, to recall that, you're going to hit the second key and the enter key. It should say entry right above it. So second enter is going to pull back what you have just typed in, and it allows you to move your cursor back and change that plus sign into a minus sign. And then just hit enter again, and you don't have to type the whole thing all over again. Okay? How many knew that? Okay. What do we get with the minus sign in the formula? 32.72? Okay. Now, my question is, if this is saying I can make a profit of $200 by pricing those CDs at $15.28 or at $32.72, how can that be? How can I have two different prices still get me the same profit?
You either sell more at $15 or sell less at $32.
Exactly. If I price it at $15.28, more people are willing to pay that and buy it. If I charge $32.72, I'm not going to sell as many CDs. I make more on each one, but I don't sell very many. Does that make sense? Okay. So the question said, what is the smallest amount we can charge and still make $200 profit? This would be my answer. Okay. All right. So we have been talking about the quadratic formula. And the other day I mentioned the term discriminant. Discriminant is that piece underneath the square root. So it doesn't include the square root symbol, it's just the b squared minus 4ac part. And we mentioned with our graphs a couple days ago, if the discriminant is positive, like the one we just did about profit, we had the square root of 304. 304 is a positive number. We got two answers out. So that means we have a graph that's going to cross the x-axis in two places, and we would say we get two real solutions. So if I say how many solutions am I going to get, you'd say two. If I say what kind are they or the type, you'd say they're real. If it comes out that discriminant is equal to 0, then in my big quadratic formula, the whole square root part is just going to drop off. All I'm going to have left is the negative b and the divide by 2a. That gets me one real answer, which means I'm just touching the x-axis in one spot. And then we've come up with a few examples where we come up with a negative discriminant. That's where we have to worry about that imaginary idea. And we'll talk more about that next week. So for now, we're just going to say there's no real solutions. Means my graph doesn't cross the x-axis at all. The discriminant is really handy for predicting if something is possible. Our next example, well, let's calculate a couple discriminants first. We do have to have it equal to 0 to identify our A, B's, and C's, just like we do with the quadratic formula. So let's bring that negative 5 over. And then we're going to analyze b squared minus 4ac. So I'm going to have negative 3 squared minus 4 times negative 2 times 5. When we simplify that, we have 9 minus negative 40. So 9 plus 40, or 49. And because I'm getting a positive answer, that tells me what? I get 2 solutions and they are real. Means if I graphed it, I would actually see it crossing the x-axis in 2 spots. Our next one here. B squared minus 4ac, we already have it equal to 0, so I'm going to go ahead and dump them in. Negative 3 squared minus 4 times 2 times 7. What do we get here? 9 minus 8 times 7 is 56. 9 minus 56 is? I think 10 minus 56, right, would be negative 46. Okay. So, because we're getting a negative value, it means what? If the discriminant is negative, no real solutions. All right. Go ahead and do the next one. I'm going to work it out on the board here, but I want you guys to try it on your own. All right, check your answer. Did you get a positive 56? All right, which means what? 2 real solutions. All right. So, as I was starting to say before, the discriminant is nice because it can tell us if something is even possible. Picture a softball going up in the air, gravity pulls it back down, right? We have that upside down parabola. The discriminant is going to allow us to figure out, can it get to a certain height? So here we have an example. We're hitting a golf ball. It says it's hit into the air from a height of 1 inch above the ground. Why would it be off the ground 1 inch? Because of the t, okay? Has an initial velocity of 85 feet per second. It says the function h equals negative 16t squared plus 85t plus 1/12 models the height in feet of the ball at time t in seconds. So h is height, t is time. The height is in feet. Can you see why they put a 1/12 in here when they told us it was starting 1 inch off the ground? 1 inch is a 1/12 of a foot, okay? That's where that's coming from. Now look carefully at the question. Will the ball reach a height of 115? Not when, not how high does the ball get. It's just, can it get there or not? With this velocity and this starting height, can it get to a height of 115? So we don't have to do the whole big long quadratic formula to find out when it reaches the height. We just have to figure out if it's possible. So we're going to do the discriminant and decide, can we get a real answer or not? Okay? We are going to put 115 in for our height. And then we're going to solve and get that 0 on the one end so that we can figure out correctly what our A, B's, and C's are. If I subtract 115 to this right-hand side here, I had a 1/12. I need 1/12 minus 115. Where does that put me? Negative 114 and 11/12, yes? Okay, so now when I go and do my b squared minus 4ac, I have 85 squared minus 4 times negative 16 times negative 114 and 11/12. Now let's check how we're going to type that in our calculator. You could convert that to a mixed number, or sorry, to an improper fraction from a mixed number. You could convert it to a decimal. If you want to be exact and not have to do the whole converting to an improper fraction, we can type that in like this. We're at negative 114, right? And I want to go down another 11/12. So you have to keep in mind that the 114 is negative, but so is the 11/12. Right? We're going all the way down to a height of negative 114 and 11/12. So I'm going to subtract 114 and I'm going to subtract 11/12. So I could enter it that way. I'll give you a second. Go ahead and type that in your calculator. And then decide, can we reach a height of 115 feet? All right, so what did we get for an answer? Negative 129.6 repeating? So because the discriminant is negative, we automatically know what? There is no real answer that makes that work, which means that ball will never get to a height of 115 feet. Okay? So, make use of the discriminant. Don't go through the whole big quadratic formula if all they're asking you is it possible? All right, now, if I wanted to know when that would happen, then yes, we have more work to do, but that wasn't the original question. All right, so you guys are working on the day 2 assignment.